One of the most important thing in machine learning is features. Uh, most of the kind of if you see the sciences, they are kind of database centric. Machine learning is also database centric. So yeah, if I have a kind of a set of data, then data has features. Like I have a set of people. So I have a database of people, and this database has features: name, country, height of the person. There can be many. So if we see kind of features in machine learning, then what we guess? If I have these two features, if I have a kind of the scenario is these two features are available, then what is the probability that it will belong? Then among these two, the third feature will be X. Like a person, each person has three features. He belongs to a country, he has a name, and he has a kind of height. Now, if I say the name of a person is Joe and his height is 6 feet, then what is the kind of probability that he will belong to Egypt? A person whose country is Egypt and his height is 5 feet 8 inches, what is the probability that his name is Joe? A person, his name is Joe and he belongs to country Egypt, what is the probability his height is 6 feet 2 inches? So if we see machine learning, it's a game of features. Means how much feature rich the database is, and then kind of if I have a set of features, then getting the probability of, like if I have set of if there are total n number of features, but anyway I have set of x features, then what is the probability that this set of x feature would belong to a feature called y? Okay, so we'll see in Bayes' theorem. So Bayes' theorem doesn't talk about multiple features, two features, two planes. Okay, so if I have a database and it has two planes, and if it has two planes, in one plane now it has items, in another plane it has items. Like a person has a name and country. So country plane has countries, name plane has different names. Now there are high chance that there will be intersection. A particular country may contain a few names like that. Now question is that if I know that a particular country has a particular name in this much percentage. Okay, I know a particular country whose the country's first, what is the probability of a particular country in that plane, and then in that country, then the particular name like Joe has this much percentage. In another plane of the name, if the Joe has 1% in that plane, inside Joe, how much will belong to that country? In one plane, if I have an item, inside that item, in another plane, one item is placed inside that. If I do orthogonal, then in that plane, in that item, what is the percentage of this plane's item that is? So that is kind of biased. If two kind of features are orthogonal to each other, then if I know one feature's probability in other, then what is the reverse? Okay, so that leads to bias. But anyway, if we go to general probability, okay, so if I just consider it. So we create a sample space of the actors, means what is the sample space, and then we pick what we want. Okay, like if I say that a person name is Joe, and then what is the probability that he belongs to? He is Egyptian Jew. Joe can be belong to many countries. Now, what I have to do is I have to just count how many Joes are there. In each Joe there is a tag of the country. Just count how many that. So this is bias theorem. Two features orthogonal, name and country. Okay. So inside the country, if I know the percentage of Joe, then inside the Joe, what is the percentage of that country? So two orthogonal plane. In once, if I know the probability, then what is same thing probability in other plane? Okay. So we will proceed more on kind of bias theorem now. Okay. So what can be the a scenario in multi-plane? Now, like if I say there is a plane of country and name, now there is another plane of height. Okay. Now, a person name is Joe and his height is 6 feet. What is the probability that he belongs to Egypt? So now I have in sample the actor is Joe and height. So I have to create all the sample space where the name is Joe and height is 6 feet. All name and Joe and height is 6 feet. There is no feature like that. Feature is only 3. So this is the hybrid plane that is coming into the picture. Now this hybrid plane and plane of country, how much they interact, because bias theorem talks about two orthogonal. So we'll create another plane, hybrid plane, where name is Joe and height is 6 feet. Then inside that we'll pick how many belong to Egypt. Okay, that is one scenario. Another scenario is what about this is information means if I start getting anyway means this is simple in the sense that now I just iterate through the database. So if a database is of people, then it has 3 features. So all the features which is name is Joe and height is 6 feet, then I'll kind of list down all the features. Against that I'll just find out the tag of the Egypt and then I'll just divide and I'll get the kind of probability. Okay. Now scenario is what about there is no Joe and height is 6 feet. Okay. If that is the case, then what is the probability? So now I prepared full database. Now I am looking for a Joe whose height is 5 feet 11 inches. 5 feet 11 and half inches. That information is not there. So what is the meaning of creating sample space when it is not available at all? So in that plane, in that kind of hybrid feature plane, there is nothing. So means it is meaningless to proceed. What are the solutions in that scenario? First, we see that bias theorem is for 2 planes. Now, if we are looking for one plane, then what we are providing as input scenario, that will create a hybrid plane. Now, there are 2 planes. Now, next scenario is in hybrid plane, there is no item. In that scenario, what we can do? So, one scenario is we can do kind of a grouping, like a person whose height is in integers like 5 feet 9 inch, then 5 feet 9 inch and half, 9 and quarter and 3/4. So all fraction will come in 9 inches, like 6 inches, 7 inches, 11 inches. So it's a kind of binning or grouping that we do. So in that way, we will get a sample space. Okay. So if a person is available of height 5 feet 11 inches and his name is Joe, and I'm searching for a person whose height is 5 feet 11 and half and his name is Joe and he belongs to Egypt. So in sample space, now all the 511 point all will come. So at least I can create the sample space and then I can kind of think about then picking out the country as Egypt. This is one scenario. What is the another scenario? So there Bayes' theorem hits. So if I say that a person name is Joe and his height is 5 feet 11 inches, what is the probability that he is an Egyptian? Okay. So now I would rather say the first in sample space we first kind of try to get how many people have named Joe and his height is 5 feet 11 inches. So, okay, so what information I have? Per country, okay, like Egypt, then we have kind of Nigeria, France, or we have Canada. So inside all those countries, like we have China or we have any Central Asia country. So in our country, we will find that if there is Jew and his height is 5'11" and any kind of point. So now per country, so first idea is we have to find how many people in full sample space their name is Joe and height is 5'11" and it's kind of it's a fraction. Then per country wise we have to find what is the probability that name is Joe and then what is the probability that this is the height. Okay, that way we create the sample space. Now we know Joe and height is 5'11". What is the probability that he belongs to Egypt? What is the probability of a person belongs to Egypt? So that I have to know. Then inside Egypt, so inside Egypt again feature by feature, I have to find the probability and then we can multiply and then we get the probability of that feature in that country divided by every country's, so the total number of samples. Okay, so if we see kind of two approaches. First is finding the exact sample spaces and then exact kind of in sample space exact what we are looking for. That is one scenario. Then we do the binning or grouping, so to increase the probability. Third is we go by feature and then it is like independent event, like if I toss a coin 3 times, then 3 independent event happens. Then we keep multiplying the kind of event probability and we keep getting less and less and less. Okay, this is kind of one flow that we get in the Bayes theorem. What is next? How? So like if I say that my sample space is this big and inside that I have to pick this. So this is the best one. Means I know that in my sample space whatever we need, those items are there. Inside that we can pick what we is the required. Next thing is, so this is the best thing. Next thing is, it is not available. Then we can do binning, grouping. So in a group, we will group the feature items, and then we will try to create sample space and we will try to find out. Obviously, this will be kind of less probable. If it is not available, then again per class wise we will go and there feature wise we will as an independent event, then we will calculate the kind of probability. So now idea is if I proceed this way, then slowly the kind of the result, we can say accuracy of the result will kind of diminish. So now we will see that how nicely we can kind of proceed. So learning process of the Bayes theorem, the algorithm, or I can rather say the data structure that we fill, we create the model. So how we can make kind of learning process in a way, in a quantized way, that first, second, third, from the third scenario also, we can kind of reach the first scenario. So those things we'll see. So multi-feature, and then in multi-feature, multi-planes, that we have to create hybrid plane and come up with the 2 plane, and that if we don't get the exact sample space, then binning, and then independent event, and then how things we correlate, so that kind of a maximum result will give. Then we will kind of try, like it's a famous, like if I have a set of documents, like one is talks about horror stories, and one talk about kind of love story, and one talk about social kind of information, one talk about patriotism, and there are so many classes that books are divided in. So first we'll make it learn the the model, then we can place any book and we'll see if it really belongs to what we are looking for. So that means